Factoring is a skill that we learn and use at all levels of math. Now, before we get started with that, let's get an idea what some of these words mean. So, first off, if we're factoring, generally we're looking for factors. Now, there's a couple of different ways that we can define the word factors. For today's lecture, I'm going to define it as things multiplied together. So if I said 2 times 3 is 6, on this side we have two things joined by multiplication. So here we would have two factors. Now this is different than, say, addition or subtraction, because when we have things multiplied together and we say that they're factors, we also say what they are factors of. So here we could say that these are two factors of 6 because they're a product, or when we multiply them together we get an answer of 6. Now this also leads into another way to define the word factors. Since 2 times 3 is 6, that means 6 is divisible by 2. Since 6 is divisible by 2, we can say 2 is a factor of 6. 6 is also divisible by 3, which means 3 is also a factor of 6. And of course there's two more, of course 1 and 6 both go evenly into 6, so those would also be factors of 6. But for today we're going to be thinking about factors as things joined by multiplication. So if factors are things that are joined by multiplication, factoring is going to be rewriting things joined by addition or subtraction into things joined by multiplication. All right, so pretty straightforward. Now, factoring is a process, and we're going to see it's a step-by-step process that we're going to do. We're going to try one thing and try something else until we get all the way to the end of our process. The first thing that we always try when factoring is something called the greatest common factor, which we generally abbreviate GCF. Now, the greatest common factor is actually an application of something we know just backwards. If I were to write this property on the board, that's AB plus AC, a lot of you would recognize this as our distributive property. Right? It tells us how to distribute multiplication across addition. On this side we have two things multiplied together, the A times the B plus C, so over here we have two factors. But on this side we have two things that are joined by addition, so we have two terms. Now if I were just to write this the opposite way, what we actually get is we get a rule for factoring, because now I'm rewriting things that are joined by addition as things joined by multiplication. So let's go through a little bit of the terminology. On the left-hand side, the first term has two factors. It has an A and a B. The second term also has two factors. It has an A and a C. So if we're looking at all the factors in the first term and comparing them to all the factors in the second term, they have a common factor. Both terms have an A. This tells us how to factor it out. Now, technically, there's a step that's missing here in the middle of what's actually happening. So if you think about it from this side, as we went from this side to this side, we multiplied, which means if we go from this side to this side, we got to do the opposite, which is divide. So what's actually happening here is once you take out your greatest common factor, that's the thing that they had in common, they both have a factor of A, then you have to take both of these terms and divide it by that. Now this step we don't normally write, we generally do that kind of in our head, but you can kind of see on the inside, A divided by A is just going to be 1, so it'll be B, and A divided by A is 1, so that is C. Okay, so this is our basic idea for taking out the greatest common factor. We figure out what the greatest common factor is, pull it out front, divide each term by the greatest common factor, and that's what's left inside the parentheses. So all that's left, besides actually doing some examples, is how do we determine what the greatest common factor is? Well, we're going to break it into two parts. We're going to look at the numbers separately from the variables. When you're looking at the numbers, you want to find the largest number that divides evenly into all the coefficients. Now remember, coefficients is just the number in front of the variables, or if there's no variable, it's just the number. For our variables here, we're going to take the, we'll just go ahead and take the, let's go like this, the variable raised to the lowest power it occurs. So basically, if they all have some power of x, we'll be able to bring out some x's. Now, how many x's will we be able to bring out? Well, it's going to be the lowest power we see on any of the x's. Okay, so let's start back over here. And here's our directions. Find the greatest common factor, then factor it out. Okay, so those are our directions. So let's say we start out with an expression, I don't know, 5x squared plus 10x. So by starting with this, our first step in factoring is always going to be look for a greatest common factor. Here we have two terms. Do those two terms have a common factor? Well, let's start out. Always look for the numbers first. What's the largest number that divides evenly into both a 5 and a 10? Well, the answer to that's going to be a 5, because 5 goes into 5 and 5 goes into 10. Since they both have x's, we're going to be able to bring out some x's. The lowest power on an x, here's an x squared, there's an x to the first, so the lowest power on an x is the first. So 5x is our greatest common factor. Now for this very first example, I'm actually going to show this middle step right here. After this first example, I'm just going to kind of do that part in our head because you need to get to that point. But if you're still struggling, this middle step right here can be really useful. So let's see, what do? We take out the greatest common factor, then we divide each term by the greatest common factor. So let's see, there's our 5x. On the inside, the 5's reduce to a 1. X squared divided by x is just x, plus 10 divided by 5 is 2. The x is reduced completely, and we're done. Okay, so is this factored? Well, if you notice, everything here is joined by multiplication now. And you're like, well, there's addition here. But that whole thing is now treated as one thing since it's in parentheses. If I were to ask you how many factors we have here, most students would say 2. You'd say it's a 5x times an x plus 2, the two factors being the 5x and the x plus 2. However, you're a little bit wrong, because remember, this is also multiplication between the 5 and the x. So technically, there are 3 factors here. The factors would be a 5, an x, and the x plus 2. All right, so let's try a couple more of these, just taking out the greatest common factor. Let's see here. Same directions, find the greatest common factor, then factor it out. Let's say we have 4x squared y plus 2xy minus 6x cubed y squared. All right, a little bit harder, so do me a favor. Hit pause on the video, see if you can find the greatest common factor, and then if you would like, go ahead and try to factor it out. All right, if you're back, let's see how you did. So looking for our greatest common factor, we're going to look at all the coefficients first. We have a 4, a 2, and a 6. The largest number that divides evenly into all of those would be a 2. Since all of these have an x, I know I can take out an x. The lowest power on an x, that's the one right here in the middle, that's just a 1, so we can only take out 1 power of x. They all have y, so I can take out a y, and the lowest power on the y is the first power. So my greatest common factor is 2xy. Now, to take out the greatest common factor, remember we write this out front, open up some parentheses. So what do we get? Now remember, this is division. So if you need to write this step like this, taking each one of these terms and dividing it by 2xy, feel free to do that at first, but you do want to kind of get past that eventually. So let's divide here. 4 divided by 2 is 2. X squared divided by x is x. Y divided by y is a 1, so we don't need that one. Now here's where the most common mistake on this type of problem happens. You say a 2xy, I took a 2xy out, and you'd say, okay, I got nothing left over, and then you'd move on to the next term. By the way, I'm making a mistake here, so don't copy this. 6 divided by 2 would be 3. X cubed divided by x would be x squared. Y squared divided by y is y. So a few of you out there, when you did this on your own, you probably have this as an answer. Now you can see that this has to be wrong, because remember, these two things have to be the same thing. We're just rewriting it. And if we distribute this 2xy back in here, notice we'd only get 2 terms, but our original started with 3. So over here, if we distribute the 5x back in, we get a 5x squared plus 10x, exactly what we started with. So a nice little hint here to make sure that you haven't made a couple of mistakes is, inside the parentheses, you should always have the same number of terms that you started with. So inside my parentheses, I need 3 terms. Now this is why you want to think about it as division, because you thought about it, if you made that mistake, it's 2xy, you took it out, so you have nothing left. No, you need to think about this as division. 2xy divided by 2xy is a 1. Now, of course, this one was correct if you did it like that. Now you can see if we distribute that back in, we get the exact same thing that we started with. All right, let's try another one, maybe a little bit more complicated. Let's say if we have 10x squared x minus 3 to 4 plus, let's do 4x cubed x minus 3 squared. All right, pretty scary looking, so let's do the same thing. Do me a favor, hit pause, see if you can find the greatest common factor, and if you can, go ahead and factor it out. All right, if you're back, let's see how you did. Now this one's scary because we have this weird x minus 3 thing here. Let me rewrite this real quick. A lot of students struggle on this, but if I had given them this problem and said, find the greatest common factor and factor it out, most of you could do this, but this one really intimidates you. That's because we got this weird x minus 3 thing. Here's the thing, we want to treat that like it's its own thing, like it's a brand new letter. Like we have x, y, z's, and x minus 3's, whatever an x minus 3 is. So you're treating that like a single letter, just like I just replaced it with a y here. So let's see what our greatest common factor would be. For our numbers, let's see, the biggest number that goes in both a 10 and a 4 would be a 2. Both of these have just x's, and the lowest power would be x squared. They both have x minus 3's, and the lowest power on an x minus 3 would be a 2. So that's our greatest common factor. So like always, we write this out front and open up some parentheses. Now I'm going to do square brackets here just so it's a little bit easier to see, but parentheses here are just fine. Now remember, this is division. 10 divided by 2 is 5. X squared divided by x squared is 1, so you don't necessarily need to write that 1. X minus 3 to the 4th divided by x minus 3 squared. We took out 2 of them, so we still have 2 left. Plus 4 divided by 2 is 2. X cubed divided by x squared, we took out 2, so we still have 1 left. X minus 3 squared, we took out x minus 3 squared, so we don't have any more x minus 3's. All right, pretty ugly looking, but the whole idea for this concept is we need to start thinking about when we see stuff like this as one thing, one animal. It's just an x minus 3, like a brand new letter. All right, so for every problem that we run into from now on, we're always going to try taking out the greatest common factor first. We always want to do that. Now, it's going to be kind of a flow chart, kind of a step-by-step thing we're always going to want to try, and I'm going to get it started over here. Step 1, we're always going to look for a greatest common factor. Now, step 2, we have a lot of choices in it, because after we get past taking out the greatest common factor, the number of terms that we start with, or the number of terms that we end up with after we take out the greatest common factor, tells us how we're going to have to approach the factoring. So step 2, we're going to say, classify how many terms. What I mean by classify how many terms, we're going to look at this like this one has 3 terms. We're going to approach 3 terms a specific way. Or the first one we did has 2 terms. We're going to approach that a very specific way. Believe it or not, this has 2 terms, right? All that's 1 term plus all that's the next one. So let's take a look at our first kind of method for factoring. Of course, we always take the greatest common factor out first. Well, let's look at factoring by grouping. Now, when we're factoring by grouping, we're always going to be looking at 4 or more terms. So over here, if you have 4 or more terms, we're always going to factor by grouping. So let's take a look at a quick example of this. Let's start out with, let's do okay. So if we were given this example here, let's see, what we'd always want to do is follow our steps. First step is greatest common factor. Now this is the step a lot of students forget to do. They skip past it and start doing other things. So a nice little trick you may want to take a look at doing to make sure that you don't forget it. When I look at this, is there a number that's in common with a 3, 6, 5, and a 10? Now, 1 always is a common factor, but unless there's nothing else, most of the time we don't do it. So, and they all don't have x's, so I can't take this out. So right next to it, I'm just going to say, you know what, this thing's got no greatest common factor, just to kind of remind me that I need to look for that. All right, so once we've taken care of the greatest common factor, either there's no greatest common factor or we factored it out, then you say, okay, how many terms do I have? Well, here I have 1, 2, 3, 4 terms, so I'm going to try factoring by grouping. Now here's where it gets interesting, because there's a lot of different ways we could group this. Now grouping just means we're only looking at certain parts of the problem at one time. We could look at the first 3 and kind of ignore that last one. We could ignore the first one and look at the last 3, but most of the time when we're grouping, we're going to treat it kind of like 2 separate problems to start with. We're kind of look at the first pair, then look at the second pair. All right, so if this was just a brand new problem on the board, 3x squared plus 6x, the first thing we want to do is look for the greatest common factor. Well, they do have a greatest common factor, and it's a 3x. If I take a 3x out of both of those, I'd have an x plus 2. Bring down our plus. Now, the second pair, again, like a brand new problem, what's the greatest common factor out of those 2? That would be a 5. And I would be left with x plus 2. All right, from here you can see that this is not factored yet because we have all of this plus all of that. So there's still 2 terms up here, which means it's not completely factored. But now we've went from 4 terms to 2, so it's kind of more factored. Now what we're going to do is treat this like one big problem again, but now we only have 2 pieces. Do these 2 terms have anything in common? So again, we're looking for the greatest common factor again. And let's see, number-wise they don't. This one has an x, that one doesn't have an x. This one has an x plus 2, and that one has an x plus 2, so we can factor out the x plus 2. So if I take out the x plus 2 and open up some parentheses, from the first term, if I divide this by x plus 2, I'd be left with 3x plus, from the second term, if I divide that by x plus 2, I would have a 5. Okay, now this is factored, and we have 2 factors. We have x plus 2 times 3x plus 5. So this is one term with 2 factors in it. Now there is one more step, and if you're keeping up with your notes, you may not want to write this one yet because I got a lot of stuff to fill in here. The very last step, which I'm going to squeeze all the way down here to the bottom, is one question you always want to ask when you're factoring is, can I factor any more? So basically look at each one of the factors once you've factored it and say, can you do anything else with an x plus 2? At this point, no. And can we do anything else with a 3x plus 5? And the answer is no. So this is completely factored. All right, let's try a couple more of these. Okay, so again, our directions are factor or factor completely, maybe this. The first step in factoring is always greatest common factor. So if we're looking at all these pieces, they do not have an overall greatest common factor, right? There's no number that goes into a 5, 27, and 28. And they all don't have x's, so we can't take x's out of everything. All right, so that's done. So again, a nice little trick is maybe doing something like this. Next to it, go, no, GCF. All right, step 2 is classify how many terms. Well, in this one, I have 1, 2, 3, 4 terms. So we're going to try factoring by grouping first. Most of the time, you're going to want to try the first pair and the second pair. So I'm going to look at this as one problem and that is one problem. So out of the first pair, let's see, the greatest common factor would be a 5x, and if I take that out, I'm left with an x minus 4. Now this one is where this example gets tricky. Now that minus comes down, and you say, okay, what's the greatest common factor out of the second pair? And you'd say that, well, that's a 7. Now I'm about to make a mistake, so don't write this down. So if you say a 7, if you factor out the 7, you'd have an x plus 4. Because we thought about that as a 7. It's really not a 7, it's a negative 7, right? But if we thought about it as 7. Now if you get to a stage like this, you're actually stuck, right? Because we have two terms, that term and that term. And they have nothing in common. They no longer have a greatest common factor, which means you'd have to stop right here, which means either this won't factor, and not everything factors, or you've made a mistake. So if you see something like this, you may want to check to see if you have made a mistake. Now, of course, our mistake here was this. I'll put that back in a second. We didn't factor out a 7, we factored out a negative 7, right? The minus sign came down, and when we decided our greatest common factor, we wrote it out front. So that's a negative 7. Negative 7x divided by negative 7 is x. 28 divided by negative 7 is a negative 4. Okay, now we can look at both of our new terms here, that term and that term, and look for a greatest common factor. In this case, they do have one. They both have an x minus 4. If we factor that out from the first term, if I take out the x minus 4, I have a 5x. Minus, from the second term, if I take out the x minus 4, I have a 7. Okay, we now have two factors and one term, all that's one giant term. So this is factored. Remember our last step, we do want to check to see if it can factor more. So here I have an x minus 4, that doesn't look like that'll factor anymore, and a 5x minus 7, nothing I can do with that, so this is factored. All right, let's try one more here. Give us a little bit more room. All right, let's see. Let's do, let's see if this works out. Okay, so here we're told to factor this. Our first step in factoring is always greatest common factor. In this case, we actually do have a greatest common factor. Let's take a look. What number that would go into all those would be a 2, and they all have an x, so I can take out some x's. The lowest power of x is 1, so let's put the x here, and I'm going to use some brackets here to make it easier to see. So we divide everything by our greatest common factor. What do I end up with? Well, that's going to be x squared minus 3x plus 3x minus 6. Okay, so I took each. That's not right. Okay, so for each one of these, I divided it by 2x. Okay, so we took out our greatest common factor. Now, that doesn't mean we're done, except for we're kind of done with that 2x. It's out front. So now we're looking at this piece inside there as kind of its own problem. This 2x just kind of comes on down. So on the inside here, I see 4 pieces, so I'm going to factor by grouping. Out of the first pair, I can take out an x, and I'd be left with an x minus 3, plus, out of the second, x minus 3, plus, minus out of the second pair, I can take out a 3, so if I factor out a 3, I'm left with x minus 3. So inside the square brackets, I now have 2 terms inside of there. They both have an x minus 3. If I factor that out, from the first term, I'd have an x, plus from the second term, I'd have a 3. Now, since all of this is joined by multiplication, I can drop those square brackets if you'd like. And we are factored. Now, last step, can I factor this anymore? Can't do anything with a 2x. nothing I can really do with an x minus 3 or an x plus 3. So this would be factored. So remember, even though you take out a greatest common factor, doesn't mean you're done. You look inside the parentheses like that's a brand new problem and see if you can factor that. What have you taken out as your greatest common factor? Just keeps riding on down all the way. All right, this is our first kind of steps in factoring. We're going to finish this up in a later video to completely learn how to factor.